Hi everybody, it's Miss Sawyer, and I want to welcome you back for the first set of new notes for Algebra 2. So we're going to get into this and talk about the real number system. So today we're going to take some of the things that were talked about last week, and we're going to break them into smaller, more manageable pieces and make sure everybody knows what they're talking about. So let's get into this. So when we talk about the real number system gets broken into all these different categories. Okay, you have natural numbers, whole numbers, integers, rational numbers, as well as irrational numbers. All of these are considered to be part of the real number system. So we're just going to run through and make sure everybody knows the notation to use, as well as which things qualify as which pieces. So let's start at the very inside of this whole thing. So when we talk about natural numbers, okay, again, the symbol you're using for natural numbers is an N. Natural numbers are otherwise known as counting numbers. Okay, so counting numbers. So we're talking about numbers that start at the number 1 and keep going up from there. Okay, so if we're talking about natural numbers, we're talking about only whole numbers. Okay, but we only start at the number 1. When we talk about whole numbers, okay, whole numbers, we're going to use the W for whole numbers. Whole numbers are going to include all of these numbers from the natural numbers, but we're also going to include 0. We're going to start at 0 and count up. The thing we're not going to include, we are not going to include negatives. We're not going to include decimals, fractions, any of that. Okay, so natural numbers start at 1, count up. Whole numbers start at 0, count up. Integers, okay, integers, the notation for integers is that Z. Integers are going to include everything from the whole numbers, so 0, 1, 2, 3, 4, etc. But we're also going to go back and include the negative numbers now, okay? Still no decimals, still no fractions, okay? But that's what our integers are going to be. Anything that's considered a whole number, positive, negative, or 0. When we get into rational numbers, okay, rational numbers, we're going to be using a Q for rational numbers. Rational numbers are going to include all of these. So let's copy all of those because we still get all of our integer numbers. But this time, not only do we get those numbers, but we also get numbers that are considered to be fractions. So things like 1/2. We're going to get things that are good, anything that can be represented as a fraction. So like, let's say, for example, 8/3. 8/3 is a repeating decimal, but that's okay because I can express 8/3, because I can express that decimal as a fraction with both numbers being integers and the bottom number can't be 0. So there's a little tool that I like to use on a website called Calculator Soup. And there's an app on there that you can use if you don't have access to a really nice calculator. There's an app on Calculator Soup that if you're not sure if you get a repeating decimal, or you're not sure if that number is going to be a rational or an irrational number, you can use Calculator Soup to convert a decimal to a fraction. So if you're not sure about a decimal number, go and check out Calculator Soup and see, can I convert that number from a decimal to a fraction? If you can, then it's considered a rational number. If it tells you you can't, if it tells you it's the same decimal that you typed in, then that means it's not a rational number, it is a irrational number. So irrational numbers, we're going to use a P for irrationals. These are things like, and you saw this on the previous video if you got to watch it, things like pi, things like the square root of 2. Okay, these are going to be decimals that don't repeat, they never end. These are going to be our irrational numbers. Okay, things like the square root of 17. Sometimes you'll see things like 2 square root 3. Again, because what's under here is not a perfect square, these are all going to be considered to be irrational numbers. But the trick that you have to remember here is that just because we call something, let's say, a whole number, doesn't mean that it's only just a whole number. So I'm going to run through a couple of examples with you really quickly to show you the difference that we have to make sure when we classify these, we give it all of its classifications. So let's take a look at this page. So here, for example, 5, 6. If I go back here, we said 5, 6, we said numbers that can be expressed as fractions are rational numbers. But rational numbers are also part of this bigger real number system. So that means that 5, 6, not only is 5, 6 a rational number, it's also a real number. Same thing happens here with 35.99. Well, 35.99, this is what we call a finite decimal. It ends right here. Well, that means that this can, in some way, shape, or form, be expressed as a fraction. So that means we're still looking at a rational number. And if it's a rational number, automatically it's a real number. Okay? So all of these things that you're going to be looking at here, they are not only most likely going to be rational numbers, they are also, if they're rational, they're always real. If they're irrational, they're still always real numbers. Okay? Real should be part of almost every answer that you're going to be giving. Now, the number 0, if we go back here and look, where did 0 first show up? Well, 0 first showed up here in the whole number section. So if 0 is a whole number, that means everything further outside of that is going to be included. So let's go back. So 0 was part of the whole number set. That means 0 is also going to be part of my integer set. If it's part of the integers, it's part of the rationals. And if it's part of the rationals, it's part of the reals. So if we go back and look, part of the wholes, part of the integers, part of the rationals, part of the reals. And I think I forgot to mention real gets denoted with an R. So when you look at these numbers, find the innermost circle that it's part of. So 4 and 1/8. We've got a fraction being expressed here. So we find the fraction section. That's rational. If it's rational, it's always going to be real. So that means this one is going to fall back under rational and real. But now here, the square root of 5. If you're not sure if this is a perfect square, put it into a calculator and find out. Well, the square root of 5 is a never-ending decimal. Your calculator might end it, but it's a never-ending decimal, which means if this is a never-ending decimal, we can't write this as a fraction. I mean, we could write it as square root of 5 over 1, but that's not going to help us to simplify this any. So we are going to call this an irrational number, but just because it's irrational doesn't mean it's not real. Let's take a look at negative 80. Where would negative 80 fall in our categories here? Well, negative 80 would be, if we're talking about negatives, the negatives only got included in the integer section. So we're going to have integers, rationals, and reals. So integers, rationals, and reals. Same thing going on here. We have 12 over 3. Well, go back and look at what we did with the previous fraction. Fractions, we said were rationals and reals. So rationals and reals. Now, people will tend to think that this number, the square root of 100, would go with something like the square root of 5. Well, the only difference between this problem and this one is the square root of 100 is actually the number 10. Well, that means that I not only now have I have a counting number here. This is actually in the very furthest inside. If I was counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so it's a natural number, which means it's also a whole number, which means it's also an integer, which means it's also a rational number, which means it's also a real number. So if it's a whole number, if it's one of our counting numbers and it's a positive counting number, that means it's going to fall under all of these categories. Let's slide this down and look at the last few here. So now we've got negative square root of 4, but the square root of 4 is 2, which means this number is the same as negative 2. Well, now negative numbers, let's find out where they fell in our chart. Negative numbers were the integer category. So we're going to have integers, rationals, and reals. So let me slide us back down here. So we are going to have integers, rationals, and reals. So it's going to fall under all three categories. When we get a number like 3.24, again, we have to think about numbers that were expressed as ending decimals. So if you wanted to, you could go back and look at what we had said for 35.99. We said that was a rational and a real. And our last one here, you see we've got pi involved. Anytime you get a symbol for a numeric value, that'll be things like pi, the letter I. Those things represent the letter E. They represent a number in mathematics. This right here, once we include pi, then we're going to be talking about our irrationals, and we're going to be talking about our reals. So hopefully that gives you some good tips to go and take a look at your homework on Edulastic. You don't have many problems there. In fact, there are only 5 to take a look at, and some of the examples from these notes will be in your homework. So make sure you got your notes with you. Thank you guys for watching. We'll see you soon.